Okay, our next set of notes is on logarithm properties. So let's start talking about some of the properties of logs. Now, since logs and exponentials are inverses, a lot of the log properties are very similar to exponential properties. So you're going to see me referencing them. But for example, here, if we have a to the 1, well, let's turn this into an equation. And I'm going to take any log equation and I'm going to turn it into an exponent. So this would be a to the x equals 1. And can you think of an exponent that no matter what the base is, anything to that exponent is 1? Well, yes, that would be 0. So it doesn't matter what your base is. If you have a 1 right here, log base a, so log of anything, log base anything of 1 is 0. And here, just like I told you with the exponent rules, if you have the same base, then the exponents are equal to each other. It's the same with logs. If you have the same base, then what you're taking the log of is equal to one another. Now here, if we have log base a of a to the x, that's going to equal just x, because it would be a to this equals this thing. So a to the x equals a to the x. Really, the log base a and the a are inverses, and they cancel and leave you with just that x. So that it's the same thing here. A to the log base a of m is just m. Okay, so using some of those properties, here, log base 2 of 2 to the 4th is just 4. Minus 5 times log base 3 of 1, well, log base anything of 1 is 0. And then 6 to the log base 6 of 5 is just 5. So we wind up with 12 minus 0 plus 5, which is 17. And then on this side, since we have the same base on both sides, we don't need it. We just say m plus 1 equals 3m minus 1. I'm going to subtract the m and then add the 1 and then divide by 2. Okay? So our next log property is another exponent rule. So remember, the exponent rule is that when I have the same base times x to the 3rd, I keep the base and add the exponents. So the exponent rule is that when I'm combining, keep the base, add the exponent. The exponent rule is that when I'm combining, when I multiply, I add. It's the same rule for logs, only it's not to combine, it's to pull them apart. So the rule for logs is that when I pull them apart, when I pull the m and n apart, since this is multiplication, I add. So log base a of m times n is the same as log base a of m plus log base a of n. When I multiply, I add. When I add, I multiply. So those rules are inverses of one another because logs and exponentials are inverses of one another. So here, the exponent rule for dividing is that when I divide, I subtract. So the exponent rule for divide, or the log rule for dividing, is that when you have division, you subtract. So here, to combine, when I divide, I subtract. To combine, when I subtract, I divide. That's the way I always remembered them. For example, log of 14 is the same as the log of 2 times 7, which should be the same as the log of 2 plus the log of 7. Let's confirm. The log of 14, the log of 2, plus the log of 7. Notice I got the exact same thing. And so then here, the ln of 5/9 should be the same as the ln of 5 minus the ln of 9. The ln of 5/9 the ln of 5 minus the ln of 9. Yep. Cool. All right, 2 more properties. 1 more new property. So this rule is that when I have a power to a power, x to the 3 to the 4, I multiply. So the rule is that when I have a log to an exponent, that exponent becomes a multiplier. So this becomes c times log base a of m. So that exponent just moves to the outside. And then my change of base formula we talked about the other day. This is the log of x divided by the log of a, or the ln of x divided by the ln of a. Which is handy if we have a TI-83 because we can't put this in the calculator that way in a TI-83, so we need to use the change of base formula. Okay, let's practice those two. Log of 9 is the same as the log of 3 to the second, which should be 2 times the log of 3. Let's check it. Log of 9, 2 times the log of 3. Okay, that one worked. So then log base 4 of 5 in base E would be the ln of 5 divided by the ln of 4. And in base 10 would be the log of 5 divided by the log of 4. And now, since I have a TI-84 and I can use the log base function, I'm going to try it. So log base 4 of 5, and then the ln of 5 divided by the ln of 4, the log of 5 divided by the log of 4. Notice how all 3 of those are the exact same. Okay, so here, if I have log base 4 of 4 to the 3.7, that is just 3.7. Remember we said when there is no base written, the base is 10. So this is the same as log base 10 of 5. So 10 to the log base 10 of 5 is just 5. I'm going to rewrite this one to make it a little bit easier for us to see. So this is log, when there is no base, the base is 10. And then 0.0001 is 10 to the negative 4. Log base 10 of 10 to the negative 4 is negative 4. And that one, the thing that I like the most about this one is that it's easily verifiable. The log of 0.123 negative 4. We could have verified both A and B, but not as easily as that one. So here, E and ln are inverses, so they cancel and leave me with just x plus 7. I don't know what I was doing there. This is the same as asking 2 to what power is 8. And so 2 to the 3rd power is 8, which means log base 2 of 8 is 3. We could always verify that in the calculator. Okay, so then if log base 2 of 8 is 3, it doesn't matter what the base is. If there's a 1 here, the whole thing is 0. And log base 2 of 2, well, 2 to what power is 2? That's 2 to the 1st power. So altogether, this would be 4. This exercise on 131, I usually really like, but in the interest of time, I'm going to skip it because I don't know that it's the best use of the little time that we have. So here, when you're doing log problems for me, this is how you're going, log property problems, this is how you're going to be seeing them the most often. So if we have one log and we want to expand it, then every piece needs its own log. So that means the 3, the m, and the n, they each need their own log. So this would be log base 2 of 3, log base 2 of m to the 5th, log base 2 of n. Now, anytime we have a fraction like this, anything in your numerator gets a plus in front of it. Anything in your denominator gets a minus in front of it. n squared. And then the last thing that I need to do is take out any exponents. So any exponents are going to become coefficients. So this would be log base 2 of 3 plus 5 log base 2 of m minus 2 log base 2 of n. Let's do the same thing here. Log base 5 of b to the 7th plus log base 5 of the square root of t minus 1 minus log base 5 of 5 minus log base 5 of n to the 3rd. Now, a quick note that anything to the 1/2 power is the same as the square root of that thing. So t minus 1, the square root of t minus 1 is the same as t minus 1 to the 1/2. So I'm going to take that square root out and put it in as a 1/2. So 1/2 log base 5 of t minus 1. Log base 5 of 5 is 1. And then this is 3 log base 5 of n. And then for the combine, we're going to do that same thing, only in the opposite order. So here, the first thing that I'm going to do is take my exponents, or take my coefficients and turn them into exponents. Log base 2 of v to the 2/3, log base 2 of r to the 4th. Now, anything to the 2/3, the numerator is my exponent and the denominator is my root, so this is the 3rd root of x squared. So log base 2 of the 3rd root of x squared minus log base 2 of r to the 4th plus log base 2 of d. Oh, that's v. Sorry, not x. Then we're going to combine these all into one log. Base 2. Anything with a plus in front of it goes in the numerator. Anything with a minus in front of it goes in the denominator. So this is the 3rd root of v squared. My r to the 4th goes down here. And then my d is up on the top. And that's a times d. Because when we put them all together, it becomes multiplication and division. Okay, so then here, this would be the ln of d squared plus the ln of j minus 3 to the 4th minus the ln of the square root of 2m plus 1 minus the ln of 4 squared. So, d squared on the top, j minus 3 to the 4th on the top, the square root of 2m minus 1 on the bottom, and 4 squared on the bottom. I'm going to put that in front of my root just so that I don't get accidentally confused and think it's under my root. Okay. Now, the other thing that we're going to focus on is log equations using properties. So, if you have just one log like this, we can do it the way we did in the last set of notes. This would be 2 to the 3 equals 2x plus 1. 2 to the 3 is 8. And then I subtract the 1, divide by the 2. Now, one thing that I didn't mention last time that I should have when we were solving these log equations is that we should always be checking. So keep in mind that you can't take the log of a negative. So just like with the square roots, we should always be checking our answers here to make sure that I don't ever accidentally take the logarithm of a negative number. Okay, If there was a weird thing that happened there, it's because I heard my daughter crying, so I ran out to check on her. Pause and unpause. Now I'm back. So here, what we should do is we should check to make sure that when I plug this back in, I don't get a negative in a log. So 2 times 7/2 is 7 plus 1 is 8. I can do the log of 8, so that one's okay. So for this one, before I can turn this into an exponential, I have to combine these two logarithms. So in order to combine these two logarithms, when we add, we multiply. So this would be log with base 4 of x plus 2 times x minus 1 equals 1, like that. And then the next thing that I'm going to do is I'm going to FOIL. So this would be log with base 4 of x squared plus 2x and minus 1x, so plus 1x minus 2. And then I'm going to turn this into an exponential, so 4 to the 1 equals x squared plus x minus 2. Well, 4 to the 1 is just 4, so I'm going to subtract the 4 from both sides. X squared plus x minus 6 equals 0. That factors to x plus 3, x minus 2. So then x plus 3 equals 0, x minus 2 equals 0, x equals negative 3, x equals 2. So now I need to check those. Negative 3 plus 2 is negative 1. I cannot do the log of negative 1, so that's no good. 2 plus 2 is 4. 2 minus 1 is 1. That one is my only real solution. This solution, remember, is extraneous. So make sure that you're checking for extraneous solutions. Okay, here we have the same log on both sides. So that means this is 2x minus 1 equals 8. When we have the same base on both sides, we don't need the logs anymore. So then that's just 2x equals 9, x equals 9/2. And then again, we should check it. 2 times 9/2 is 9, minus 1 is 8, so that's okay. And then last but not least, before we can cancel the logs, I have to move this 2 in. So make it the log of 7x minus 12 equals the log of x squared. I got my parentheses right there. So now we have the same log on both sides. So now I could just make this 7x minus 12 equals x squared. Subtract the 7x and the 12 and make this x squared minus 7x plus 12 equals 0. That factors x minus 3x plus 4, or x minus 3x minus 4, excuse me. So x minus 3 equals 0, x minus 4 equals 0, 3, and 4. Both 3 and 4 would work over here. So over here, 3 times 7 is 21. 21 minus 12 is 9, so that's positive. 4 times 7 is 28. 28 minus 12 is positive also, so that means both of these work. Okay, let's continue solving log equations. So here, if we have an exponential, I'm going to try to get bases the same if I can, and if I can't, then I'll use a log. So here, both 9 and 27 can be written as base 3. 3 to the 2 to the 2x equals 3 to the 3. Now you could have absolutely used logs on this and done log base 9 of 27 equals 2x. You would have gotten the same answer. But now that we have the same base, I can say 4x equals 3 and x equals 3/4. For the next one, we have a log with the same base on each side, so I can drop the logs and just say 5m minus 2 equals m. I'll subtract the 5m, divide by the negative 4, which is 1/2. Now for this one, I can't make a 3 a 4 and I can't make a 4 a 3. So this would just be log with base 3 of 4 equals m plus 2. Now, if you're asked for an exact answer, then that means to keep the log. So the exact answer here would be log with base 3 of 4 minus 2. And then my rounded answer would be what I would get if I put this in the calculator. So I would do the log of 4 divided by the log of 3, or log base 3 of 4 if I have a TI-84, minus 2. So negative 0.37. They asked me for 3 decimal places, so 0.378. 738. Now, a couple of these go beyond what we need to do, so that's definitely numbers 4, 5, and 6. I wouldn't worry about them. Again, if we were in a regular semester, I would have done those with you, but I do want to do number 7. So here, they all have the log with the same base, but before I can cancel that log, I have to get 1 on each side. So because this is subtraction, I'm going to divide these and make this log with base 2 of x plus 3 divided by x minus 6 equals log with base 2 of x minus 5. And now that I have 1 log equals 1 log, I can get rid of the log since they have the same base. Again, only if they have the same base. So that's x plus 3 over x minus 6 equals x minus 5. I'm going to put x minus 5 over 1, and I'm going to cross multiply. So x plus 3, times 1 is x plus 3. And that's going to be x minus 5 times x minus 6. X plus 3 equals x squared minus 11x plus 30 when I FOIL that together. So then x squared minus 12x plus 27 when I subtract the x and subtract the 3. That factors x minus 9, x minus 3. So x equals 9 or x equals 3. And again, we have to check these. So 9 plus 3 is 6, that's positive. 9 minus 6 is 3, that's positive. 9 minus 5 is 4, that's positive. 3 plus 3 is 6, that's positive. But 3 minus 6 is negative 3. And I cannot do the log base 2 of negative 3. And the first time it fails, it's out. So x equals 9 is my only solution. Now, I have always considered the problems on page 136 to be challenge problems. If we had been taking a paper test, one of those would have been an extra credit question. Instead, I've made some of the Unit 5 stuff extra credit, so we're not going to worry about the problems on page 136. We've covered all of the log equations that you're going to be seeing in your homework and on your test. So please make sure that you are working on your homework and that you're asking if you have any questions.